Let's begin. Today is June 22nd, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses 5 criteria cards and it's 5 verification cards. Let's go to turingmachine.info for the details. So today's puzzle uses the following 5 criteria cards. Criteria card 2, 13, 17, 19, and 20, and uses the green verification cards. The code above is your way to get more information on today's puzzle by searching that code at turingmachine.info. Let's solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, criteria card C. In the bottom row, we've got criteria card D, and finally criteria card E. So criteria card A looks at the first digit, that triangle digit, and we'll be comparing it to the number 3. So should the value in our solution for triangle be less than 3? Should it be equal to 3? Or should it be greater than 3? Criteria card B looks at the middle and last digit, the square and circle, and compares them to each other. So should the value of the square digit in our solution be less than circle? Should they be equal? Or should the square value be greater than circle? In criteria card C, we're going to look at our 3-digit solution, and the Turing Machine will let us know how many of those 3 digits are even. Are there no evens? Is there a single even? Maybe 2? Perhaps even all 3 are even. Criteria card D looks at the first 2 digits, triangle and square, and we'll take its sum and compare that to the number 6. So should the sum of those 2 digits be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E again looks at our 3-digit solution and will let us know something about its structure, specifically about if any of the digits are repeating or not. So in the first possibility, it could be that there are no repeating digits, as in the example 1, 2, 5. It could be that the solution could actually have a double number or repeating digit, as in the example 1, 1, 2, or potentially it could be a triple number, which is a single digit repeated 3 times, as in the example 2, 2, 2. Remember, our objective today is to find this unique 3-digit code that abides by all the criteria cards that we just discussed. And we're going to start off with our initial proposal of 3, 1, 4. So the first thing I want to find out is how many evens there are. So I'm going to test criteria card C. Okay, so the Turing Machine does not approve of my proposal. Notice that in my proposal of 3, 1, 4, I've got 2 odds to 1 even. It does not agree with that. So at this point, it's really wide open. So the only thing I can say is that there isn't just a single 2. So let me go ahead and put that in my notes in section C. Sorry, I may have said 2. I meant to say even. So potentially, again, there could be no evens, there could be 2, or they could all be even. The next thing I want to test is I want to see what criteria E will tell me about my proposal. So I'm going to test criteria card E. And so again, the Turing Machine does not approve of my proposal. Notice that I do have 3, 1, 4. They are all unique, no repetition. So either it's a double number or a triple number. So again, the Turing Machine told me that no repetitions is not valid. So I'll just say there is a, I'll just say double or triple number. And the likelihood that it's triple is rare, but you cannot just arbitrarily discard it. Let me see if there's anything in our clues above So let's see. I guess you could almost argue that I guess if there were a triple number, then well, no, you couldn't say that. I was going to say that you could say that they have to be all even, and that's not true. Well, maybe. It's those sort of logical leaps of faith I just am not comfortable with. So we'll just leave it at there could be a double or a triple number. Okay, wow. So far, my two selections have not really yielded any, exclusions up above. Okay, so let's go ahead. Yeah, this is rather challenging. Maybe I should have tested something else. But I'm going to go ahead and test. Let's just go with criteria card D and see what happens. Oh my gosh. Okay, so yeah, it did not like that proposal either. 3 strikes. Okay. So what we can say is that, well, in my proposal, if I do add up the digits, 3, 1, that's less than 4. It did not approve of that. So we can say that the sum of triangle and square is either 6 or greater than 6. So let's go ahead and write that down in D, that triangle plus square is either, we'll say, equal to 6 or greater than 6. Okay, so what does that mean? Let's see. If, yeah, I think that also is not going to let me eliminate anything, because I know that 1 plus 5 is 6. That's valid. All we can say is that they're not going to be 2 small digits, right? Like 1, 2 or 1, 3. Those are all sums that are less than. So it's going to be, a small and a big, or maybe too big. We just don't know yet. Wow. Okay, so, okay, yeah, well, that does it for this turn. We got 3 strikes, and now we're going to the phase where we're going to have to construct a good second round proposal to see what we can get. Okay, so let's talk about it. So we didn't test A, which would let us know a little bit about triangle, which now would be very useful now that we know that our sum is either equal to 6 or greater than 6. We also didn't test compared square and circle, and yeah, that's it. So it's up to these two. Wow, these 2 criteria, since they're the only ones left, that would help us, find our answer. Okay, so let's see. Wow. Okay, so we know we have either a double number or a triple number. Well, let's consider the triple number. Is that even possible? I guess conceive that maybe they could all be 3s. Triangle would be 3. There'd be no evens. The sum could be 6. Is that out of the range of possibility that they're all 3? I guess I'm wondering, are there more cases where the sum is 6 or greater than 6? So if they're equal to 6, then you have some possibilities. You got 1, 5 or 5, 1. You could have 2, 4 and 4, 2. And then you could have 3, 3. So I guess those are all equal to 6. And how about greater than 6? I think so. I guess that was what, 6, 1, 5, 5, 1, 2, 4, 4, 4. or 2442, and 33. I guess 33 you got to consider as just a single possibility. So that seems like there's 5 potential equal to 6, but greater than 6, it's like 2, 5 and 5, 2, 3, 4, 4, 3, 3, 5, 5, 3, 4, 5, and then some doubles. So yeah, there's definitely more greater than 6. And again, we have to whittle it down just using these 2 criteria, at this point, because we still don't quite know how many evens there are. Wow. Yeah, I go back to this 333. How rare would that be? So if that were equal to 3 and it was 6, then that forces a square to be 3. And then again, potentially you could have this middle card, or criteria card B, be equal as well, and it'd be 3, 3. Oh my gosh. Okay, so I'm going to sort of hedge my bets. Let's see. What if I have a sum of 6? If, in fact, it's, some sum of 6 where they're odd. And, well, we know there's not a single even. Okay. So if this were 1551, it would have to be an odd. It would have to be an odd. It can't be a single even. Well, that's interesting. Okay. And so how would that work? Triangle would tell you which of the 1 or 5 it would be. And then obviously square would be determined, right? Be forced to be, the other 1 or 5 combination. And then that would force possibly circle to be a third odd. So what would that look like? Like 5, 1. So 5, 1, 3, but that would be no repetition. So we're looking at a potential repetition. Okay. What if it were 6, but it'd be 3, 3? That forces square to be 3. And then circle would be either less than or greater than for the 1 or 5. That almost seems a little bit more plausible. Well, I guess, it could also be like a 511 or a 155. I could also see 3, 3, 1, or 5. So I think I'm going to go with a sum of 6. And the question is, what is going to be doubled up? Could it be the 3, 3 or the 1, 1, 5, 5? Remember, it's got to be unique. So what distinguishes it? I mean, really anything. I think it's plausible for all these. So let me go ahead and I'm going to do 155. Would they be equal? 155. So what's the difference between 155 and 511? Well, I guess this would tell us what triangle should be. Okay. Yeah, let me go ahead and I'm going to go with 155. We'll see. Wow. All right. So kind of counterintuitive. I'm going to test again the sum because that's what I based my whole premise on. So let me test criteria card D again. Oh no, it's not 6. Okay. All right. So we know it's not equal to 6. So let me cross out the equal 6. Oh, goodness. Very challenging indeed. Okay, so we know it's greater than 6. Okay, at least this, now I know I can cross out 1 for triangle and square, because 1 plus 5 equals 6. It's got to be, something greater than that. Okay, so that's that. Let's go ahead. And I tested, well, or I chose 1 for triangle. 1, 2. Okay. Let me. You know what? I'm going to go ahead and test B first. Okay, finally a check mark, and we do have. Great. We have a double number in square and circle. Well, they're equal. I don't want to say just double number, because I guess potentially you still could get a triple. But we will say that that square and circle do equal each other, since that's what I have, 5, 5. And that's in B. So let's go ahead and say square equals circle. Okay, square equals circle. So that means that obviously circle can't also be 1, because it doesn't have anything to be paired up with. Okay, so we've got 2, 2, 3, 3, 4, 4, 5, 5. The question is, which of those will be matched up? So I guess technically you've got, I guess, let's see. Well, we haven't tested A yet, and A will at least yield us something, even though I did choose 1. Yeah. Let's see. So we do have this double number. Is it worth testing C again? Let's, oh goodness, rather challenging. I don't want to test E, but I think I have to test A just to get it out of the way, because otherwise I don't want to be hamstrung in the 3rd round. So let me go ahead and test A. Okay, so it was incorrect. So it is not smaller than 3. So either triangles equal to 3 or greater than 3. So let me go ahead and write that down. Wow, this has been a rather challenging puzzle. Maybe I made some bad choices to test in round 1. So we'll say triangles either equal to 3 or greater than 3. Okay, so that means that triangle is not a 2. Yep, we can cross out this 2. Okay, and okay, well, yeah, that does it for this turn. Oh my gosh, we've done 6 tests, and I don't feel like I'm anywhere close. Okay, so can it be 2, 2? I guess if it was exactly 3, well, it couldn't be 3, 2, 2, because the sum is not greater. So we know, okay, so, and can it be 4, 2, 2? It can't be 4, 2, 2, because that sum is 6. So it could be 5, 2, 2. And we can't have, I guess, a double. Oh my gosh. Okay. There's got to be something I'm missing. Wow. I don't want this to go, at most 2 turns in the next round. 8 I can see. I don't think I've ever seen a puzzle go to 9 in these sort of challenge puzzles that you get at turingmachine.info. Okay, so we can exclude at least 433. Okay, so yeah, I think, you know what? I think I'm going to start listing stuff out because, yeah, because I see 433 and 455 cannot happen because that would be a single even, and we know that's wrong. Okay, so let me go ahead and start listing stuff out. So we said it cannot be 322 because the sum is less. It can't be 422 because the sum is 6. So we can have 522. And so yeah, I guess let me go ahead and, since I start out with 5, that's the first one, let me keep going with 5s. So it could be 522, it can be 533, it can be 544, and of course it could be 555. Okay, so that's all the 5s. Yes, 522, 533, 544, 555. Yep, I don't see anything that we've established that would disqualify any of those. Okay, so let's go to 4. It cannot be 455 because that's a single 4. I guess it could be a triple 444. It can't be 433, and it can't be 422. So again, 433 cannot because that's a single even, and 422, that's a sum of 6. So that's it for 4s. What about 3s? It can't be 322. It could be 333. It can be 344, and it could be 355. Now I think that's all of them. If I did everything correctly, I think that's all of them. So that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so are any of these redundant? So say that there are no evens. No evens. And say, it's a triple number. No evens and triple number. Well, 555 and 333 are, you could distinguish it because, you know what triangle is. So that's plausible. So I don't think I can cross it out. And then you also have, 3 evens. Are there any other 3 evens other than 444? That's the only triple even, and it could be greater than 4, and we already know that's equal. Oh my gosh, how can I how many equal 3 are there that it starts off with 3? There are only 3 of them. I could have a double even. I am torn. Okay. 1, 2, 3, 4. So there are 4 that start with 5, a triple 4, and 3 that start with 3. We're going to need to start whittling it down. So I think I'm going to go with something that starts off with 3, and either there are going to be 2 evens or no evens. Okay, so I am going to go, let's see, if I have 3, let's think about this. I want to guarantee that the sum is greater than 6. So I think I'm going to go with 344. Oh, help me. 344. Oh my gosh. Okay. So yeah, let me go test A again. Let me test. Well, let's see. How many double evens are there? 1, 2, 3. There are 3 double evens, but only one that starts with a 3. All right. Yeah, maybe that would be a good test if I tested the evens again and 4, 4, 4, 4, 5. Yeah, if there are 2 double evens, then I think I could then exclude 5, 2, 2 and 5, 4, 4 as being ambiguous. So yeah, I'm going to test criteria card C, and let's see how we do. No! Oh gosh. Okay. So, but at least at this stage, I can now start canceling some stuff. So C has revealed that it must be all even or no evens. So, so let me actually cross this out, and let me say either all, well, let me do it this, all evens or no evens. Is that correct? So I've eliminated the possibility where there is just a single and a double. So yeah, they're either all or none. Okay. So let me get rid of all the double evens. So that would include 5, 2, 2. That would get rid of 5, 4, 4. That would get rid of 3, 4, 4. Oops. Okay. So I still have some that have 3s at the beginning and greater. Okay. And there's just a single all even. Wow. Yeah. Okay. I'm going to pretend that it's not all, that there's no evens. Okay. So that would mean either it starts with a 3 or starts with something greater. Goodness, I'm totally going to get this on the Turing machine. Okay. So let's see, what can we say about if it starts with a 3 or starts with a 5? I still have a couple that could be triples, and then it's kind of the reverse. Goodness. Okay, what can I test? I know B is for sure, D is for sure. I still don't know if there's a double or triple. Oh, interesting. Interesting. It may be worth testing E again. Yeah, I think that's what I'm going to do. Test E again to see if there's a double or a triple. Yeah, I'm just going to test it. Oh my gosh. Okay, so there is a double. So I can get rid of these. Oh, I can get rid of these 3. Oh, I didn't notice it. Okay, yeah, I've got these 3 triple numbers. So I indeed do have a double. Okay, so that was very helpful, getting rid of those triple. I do have a double. So let me go ahead. Let me get rid of triple here. Okay, so we have a double, and that's what we have. And so, yeah, now it goes down to criteria A. Does it start with a 3 or not? Okay, so let's do A. Okay, it does not start with a 3. So let me go ahead and cross it out. So that means it's something that's greater than 3. Okay, so it doesn't start with a 3. And I guess again, 4. Yeah, so it can't be 4 either, since obviously I don't have any 4s. For all those reasons, well, okay. Well, yeah, it's just, yeah, it's got to be 533. So I can cross this out. So it's got to be 533. Oh my goodness. I'm just going to type it up and kind of review here. And so let's see. Does triangle start off with something that's bigger than 3? Yes. Are the last two equal? Yes. I'm going to deduce that obviously there are no evens. The sum is greater than 6? Yes. There's a double? Yes. And yeah, I guess that's it. Oh my gosh. Okay, so let's go confirm. Let's go confirm 533. I don't think I've ever gone to a 9 question or 9 query. 533. Let me just double check again. 533. Oh, come on. 533. Yes. Okay. And let's verify. I don't want to go too far so we don't miss out. Okay. Yes. 533. Oh my goodness. Okay. So I know there's no way I tied the Turing Machine. I had to have lost. All right. So C, D, E, all wrong. C, D, E, all wrong. Second round. A, B, D, middle is correct. A, B, D. A, B, D. And then last turn, E is the only one, so A, C, E. A, C, E. E. Okay, how do we do? Wow, okay, I don't feel as bad. I did lose by 1. That's incredible. I'd never gone to 9 that I can recall. Okay, well, I definitely will need some suggestions. What did I do wrong? Again, it wasn't that bad of a loss. I think it could have been worse. If I had to say something, maybe my first 3 choices weren't as useful. I know I say that just because you get X's, you can, as long as you don't commit the same mistake twice, it's a learning experience. I don't think I did that. It was a rather challenging puzzle because even the Turing Machine, it took 8 queries, but maybe I could have done better. Wow, this was a very challenging puzzle, so I don't feel as bad as the loss. So if you do have any comments, please do share. If you like this video, give it a thumbs up. But definitely, if you don't want to miss out on any future videos, do hit subscribe. Well, I'll leave you for now. Have a great one.